All right, example 4. But notice, have you ever noticed in the last couple of podcasts here that it doesn't matter what the function is, it always seems to be the same transformations over and over and over again. We find the A value, find the B value, find the H value, find the K value, and just go crazy with them. Okay, same thing, same thing. Look, this just happens to be an absolute value function. Let's draw it out. Remember, absolute value functions are those V functions. Starts at 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and so on. Okay? That also means if it's -1, absolute value of -1 is 1. -2, absolute value is 2. 3, 4, and look, you get this beautiful V going right across here. And I'm going to draw it really, really nice. I'm going to use this guy here, and I'm just going to draw it in red. Oh, look how pretty this is going to be. Starting here, right down to there. And again, I'm going to do exactly the same thing, starting here and right up all the way to there. Oh, how pretty. Perfect. Okay, so now with that in mind now, let's transform this graph. Okay, first things first. Did you see it? Look at that. 2 questions in a row where we actually have to factor this thing out. All right, so this becomes 3. Now factor this, factor this. You're going to take out a 2, so there's the absolute value. Take out a 2, leaving you with x minus 3 under the absolute value minus 4. Now, identify everything. Identify everything. Your A is 3. So again, we have now a vertical stretch of factor 3. We have a B, which is 2, so that means we have a horizontal stretch of factor 1/2. We have an H here, which is a -3. Well, no, it's not, because remember, the original formula, this may be negative. This is actually a +3. But we've got this as a K value of -4. And remember, we have to do this SRT. We do our stretches first, our reflections, then our transformations. Now, I could do them again right on the graph if you want, or I like to develop a nice little table of values, and I like to use the notation. I like to use this mapping notation down here. That to me makes all the sense in the world. So, okay, let's start looking at some graphs. Let's start looking at some points on the graph, I should say, and let's see what we can do. Okay, so here we go. First point on the original graph, x, y, because it's in red. All right, let's start with, I don't know, let's start with -4. -4, -3, -2, even that might be a little bit too much, hey? So why don't we just make this a little simpler? Let's skip some points. Let's go -4. Let's go -2. Let's go 0, 2, and 4. Now you're probably saying, why are you doing that? Why are you staying with the even ones? Why didn't you go with the odd ones? Because I know I'm going to have to multiply it by 1/2, and I'm going to get some pretty numbers that way. So remember, the y values here were 4, 2, 0, 2, 4. That's what our original function was. Now, let's take this original function and let's make it blue. There's our transform function. So using this idea, think about what we're doing every single function. Let's talk about the horizontals first. So in the terms of the horizontals, what are we doing? We're multiplying every point by 1/2, every x point by 1/2, okay? And we're moving 3 to the right. For every vertical now, we're multiplying it by 3, every one, and going down 4. Notice how SRT works, though, because it's exactly based on bed mass. Bed mass tells us to do the multiplication first, okay, and then the addition second. But think about that. Isn't the multiplication, right, the stretch and reflection? Isn't the addition and subtraction part of bed mass just your translation left to right or up or down? So bed mass and SRT follow each other just beautifully. Okay, so enough. Let's go. -4, let's do that one. Put it into the x values. -4, 1/2 of -4 is -2. Plus 3 is 1. There's our new point. Okay, let's do the exact same thing to -2 here. 1/2 of -2 is -1. Plus 3 is 2. 0. 1/2 of 0 is 0. Plus 3. Look at this. Half of 2 is 1 plus 3. Okay? 1 plus 3 is 4. Let's do it to this one. Half of 4 is 2. 2 plus 3 is 5. Oh, that's easy. Oh my goodness, that was just a walk in the park. Let's go to this one here now. Let's take this one. Okay, 3 times 4 is 12. 12 minus 4 is 8. Okay, 3 times 2 is 6. 6 minus 4 is 2. 0 times 3 is 0. That's got to be minus 4. 2 times minus 3 is 6. 6 minus 4 is 2. And then 4 times 3 is 12. 12 minus 4 is 8. Oh my goodness. Look, we've got all the points we need. Let's graph. Let's graph. Let's graph. Let's graph. So here we go. First point is 1, 8. Okay, let's find 1, 8, which is way the heck up here. Okay, next point is 2, 2. 2, 2, right here. Okay, next point after that would be down here, 3, negative 4. 3, negative 4, which is down right there. Oh my goodness. Next point is 4, 2. Okay, 4, 2, which is right here. Boom. Okay, and next point after that will be 5, 8. 5, 8, which is right here. Look at your new point. I'm going to draw this here in, let's pick a color. Let's draw it in blue. Why not blue? Okay, blue. Here we go. Look at this. We're starting here, going up through here, and we're starting here and going up through there. Look at this graph. Look how it's been moved. Look how it's been stretched. Isn't that interesting? Wow, neat, neat, neat. And once you see it on the graph, it's actually really easy to do. Let's do the domain and range. Okay, domain on this, think about it. Our original transformation, domain on that, x can be any value you want. And same with this. I mean, after all, if you look at this graph, this goes on forever and ever in this direction and in that direction. X is still, the domain is still a value of the real numbers. Perfect. But let's look at the range. The range changes because, of course, we transformed it. It's now down here. So the range says it has to be all the y values such that y has to be greater than or equal to negative 4. And y is an element, of course, of the reals. Oh, just barely got that in there. Okay, so some really interesting things, and I think you're probably, after seeing this a second time, really starting to get a hang of this.